Hope you're trying to have a productive day. In this past paper question video, we will be going through question number 5 from the 2017 Unit 1 paper 2 for physics. Now I will be splitting this video into two. I'll do 5 part A in this video, and then I will do 5 part B in the next video. And the reason I'm doing that is because this video has some calculations and I want to show different ways of doing the calculations. And there are 2 questions with multiple ways to do calculations. So I want to show more than one way, which is why the video will be split into 2. Of course, at any time, if you feel like you need to pause the video or take a break, you can do so. Absorb the knowledge, and then when you feel more comfortable, you can come back and unpause the video and continue watching. You can also attempt these questions on your own at some point if you feel the need to. All right, let's get into the question. Distinguish between the terms threshold of hearing and threshold of pain when applied to the intensity of sound. So this is something that you're just going to have to know. Even though the threshold intensity of hearing and the threshold intensity of pain, they both have numerical values associated with them for a 1 kilohertz sound. It doesn't look like they want you to be that specific here, so you just have to give them, well, the bare minimum. So the threshold of hearing is the intensity level of sound that the sound just starts to become audible, or the lowest intensity level that can be detected by the ear, whereas the threshold of pain is the intensity level where discomfort starts. So that's 5AI. Now we move on to II, or 2. What 2 properties of the human ear makes the decibel scale particularly useful? These 2 properties are things you're going to have to know. Number 1, the human ear can respond to a wide range of frequencies. And number 2, the human ear's response to sound is logarithmic. Part 3, the sound from a vuvuzela, a horn popular at football matches, can be as high as 115 decibels. Determine the intensity of such a sound in watts per meter squared. Right then, so this question, it can be worked out in 2 different, maybe even 3 different approaches, but I'm going to show 2 approaches. All right, so how would we attempt this question? Well, the first part of doing the question, you should probably ensure that you do make this a habit, is that you want to write down the numbers that were given to you in the question. I'm not going to write them down separately. I'll just put them in the equation that I'm going to use and work it out from there. But you want to write down the information that was given. So what information was given? You have the 115 decibels, and then it tells us that a threshold intensity of hearing is 1 times 10 to the minus 12 watts per meter squared. So you have those 2 bits of information to write down. Then you're going to probably need a formula or 2 if you want to work through this question. So what is that formula going to be? Well, the intensity level or sound level in decibels, so we can call it intensity level in decibels, is equal to 10 multiplied by log base 10 of the intensity you are trying to find divided by the threshold intensity, and that's it. So this is the formula. So basically the question gave us the intensity level, which was 115 decibels. So we have the 10, we have log base 10, and then the intensity that we're trying to find is what this top one is, and then it also gave us a threshold intensity of hearing, which was 10 to the minus 12 watts per meter squared. So we have that. So if you're looking at this question, you might see some things that you're like, what exactly is this log thing that this guy's talking about? All right, so I'm gonna work this question in 2 different ways. The first way will be a little bit longer, but it should help you understand a little bit better. And the second way is just going to be, if you understand logarithms, then you can just basically do it the second way, and the second way is kind of faster, simpler as well. But for the sake of explanation, let's do the first way, which is a bit longer. So log base 10 I over 10 to the minus 12. What does all of this mean, and how can we solve for I when we're given all of this information? So one of the rules of logarithms is that if you have log base x of, let's say, a over b, this is equal to log base x of a minus log base x of b. We'll get into what the log actually means as we approach it, but let's just work with this for now. So now that we have this relationship here, we can basically write this out in a different way. So we can write 115 is equal to 10 times log base 10 of I, which is this over here. So the I is the A, which means the B is a minus 12. So we can write minus log base 10 of 10 to the minus 12. All right. So over here, this 10 is being multiplied, or this 10 is multiplying all of this. It's multiplying this term here. So we can just go ahead, divide this side by 10, divide that by 10, and we're going to get 11.5. So we're going to get 11.5 is equal to log 10I, which is what we're trying to find. We're trying to find I, minus log base 10 of 10 to the minus 12. All right, so let's work out what a log is. All right, so here we have log base 10 of 10 to the minus 12. How do we find this number? Because all of this is just equal to one number. All of this is just equal to a single number, right? But we're trying to find what that number is. So let's just say what a logarithm is, right? So if I have log and I have a base here, let's say base x, and I have a number here, call it y, and I say that is equal to the answer. You can put a question mark for the answer, right? What is the answer? Well, log base x of y is basically the same thing as saying x raised to the answer gives me y. That's a logarithm. Might be a little bit confusing. Let's just go through it again. Log base x of y is basically saying x raised to what number gives you y. You get what I'm saying? So let's work it with an actual example here. So if I have log base 2 of 8, what is that answer equal to? I'm basically saying 2 raised to what number gives me 8. So 2 raised to which power gives me 8? If you don't know what that is, you can just multiply 2 until by itself until you find the answer. So 2 to the 0, that's equal to 1. 2 to 1 is equal to 2. 2 to the 2 is equal to 4. And then 2 to the 3 is equal to 8. So 2 to the 3 equals 8, which means that 2 raised to which number gives me 8? That answer is 3. That's basically what logarithms are. You're just trying to find what number is the base raised to give me the number here, right? Another example, let's say we have log base 10, like what we have over here. This is log base 10. Log base 10 of, let's say, 1,000 is equal to what? What number must 10 be raised to give me 1,000? The answer again is 3. 10 raised to 3 gives you 1,000, right? So that's basically what logarithms are in their most raw state, in their simplest form. So let's try to find this number here. So log base 10 of 10 to the minus 12. What is that number equal to? You can type this up on your calculator, or you could work it out right now. So 10 raised to what number gives me 10 to the minus 12? The answer is kind of there already. This is 10 to the minus 12. This is 10 to the minus 12. So what must 10 be raised to give me 10 to the minus 12? The answer is minus 12, right? Because it's already 10 raised to the minus 12, right? So, saying that to say this, we can write 11.5 is equal to log base 10 of I minus negative 12, right? So you see that's what this number equals to. It's just basically a fancy way of saying negative 12, right? By the way, if you're trying to do this on a calculator, you can look for the log function of your calculator and then type in open bracket 10 raised to the minus 12, and the answer should be minus 12. Also, on your calculator, the default base for your logarithm function is 10. So we can continue rewriting this equation. So we can write it 11.5 is equal to log base 10 I, and then since we're subtracting a negative number, we're actually adding. So we'll have 12. Then we can take the 12 from this side, we can subtract 12 from that side, and then we can subtract 12 from this side, right? So now we get 11.5 minus 12 is equal to log base 10 of I. All right. Then we can finally rewrite this and say, what is 11.5 minus 12? The answer is negative 0.5 is equal to log base 10 of I. So there you go. We're still trying to find I, by the way. All of this is just the long way of finding I, right? So we're trying to find I. There it is. We have log base 10 of I. So now we need to do logarithms again. But this time, instead of trying to find the number over here, instead of trying to find the 3 in this instance, we're trying to find what number the 1,000 would be, right? Because we're already given a 3 in this case. The 3 in this case is the 0.5, right? The negative 0.5. And then the 1,000 would be the I. So we're trying to find the I. So let's ask the question one more time. Log base 10 of I is equal to negative 0.5. So let's ask a question. 10 raised to what number gives I? But we're trying to find I. So all we have to do is say 10 raised to 0.5, and that answer is going to be I. So if we're trying to find I, we just have to basically say 10 raised to the negative 0.5, right? So all we have to do is say 10 to the minus 0.5, and then we type is equal to. So you can go ahead and punch this in on your calculators. You can say 10 raised to the minus 0.5. And you get an answer of 0.316. And the units, have to remember your units, watts per meter squared. And that is the final answer for this question. I'm going to show you an easier way to get the same answer if you are running out of time and you understand how logarithms work, right? Okay, so an easier way to do what I just did. Let's say you have this, right? So let's do the same thing. Divide this side by 10. Divide that side by 10. We're going to get 11.5 is equal to log base 10 of I over 10 to the minus 12. So instead of splitting these two and working them separately, let's just work it as one. So basically we're saying 10 raised to this number gives us that. So just like in the last part of the last approach, we're going to say 10 raised to the 11.5 gives us I over, I don't know why my writing is so slanted. Here we go. I over 10 to the minus 12. So all we have to do is take 10 and raise it to the 11.5. And don't be startled, you are raising 10 to an exponent of 11.5. The number is going to be quite large. So we're going to raise 10 to 11.5 and we're going to get a number. That number is 3.162 times 10 to the 11, right? Just short of a trillion. And that is equal to I over 10 to the minus 12. So we're trying to find I. All we have to do is multiply this side by 10 to the minus 12. Since we multiplied this side by 10 to the minus 12, we have to do the same over here to maintain the equation. So we multiply this side by 10 to the minus 12, like that. And then our final answer is going to be, oh, I just cleared my calculator. Hold on. Look at that. It's going to be 0.3162. Don't forget your units, watts per meter squared. And as you can see, we got the same answer as the previous way of working out the question. So why was this one easier? Well, we never had to do any logarithms, so to speak. Once we got here, it was just algebra. We only had to do the logarithm thing like once, and that gave us this, right? And then once we got this, we just solve for I, and that looks much more familiar to you, so you can easily solve for I, right? So this approach is if you know what the logarithms mean. So because I know what this entire statement means, I know that it just means 10 raised to the 11.5 is equal to this. So I just write out that statement and then I get this answer, right? So it's an easier way to do logarithms. But if you don't really understand it perfectly, there's another thing that you could do. So just as how you have sine theta is equal to 45 and you want to find theta, you just say sine inverse on your calculator of 45 and that gives you theta, right? So is there a similar function for log? Turns out there is, and that's the thing that we just did. When you have log base 10 of something that you don't know, and that's equal to an answer, let's say 3, on your calculator you can press shift, then click log, and then you'll see a 10 come up, but the 10 looks kind of weird. That just means 10 raised to something, and then you put the number over here. So basically you would write, this would be the small 10 that looks like this, I guess. And then you write 3. You just type up 3 at the end, like that. And then you press equal to, and then it gives you this number here, which in this case is 1,000. So 10 raised to 3 is 1,000. Multiple ways to go about using your calculator and multiple ways to go about logarithms. You just pick one that's comfortable to you. And when you feel more comfortable with logarithms, maybe after you've done some more math courses or something like that, you can use more straightforward ways, you can use easier ways, you can use different ways. But I'm just showing you the options that exist for this kind of question. And that brings us to the end of 5 part A. So these are the calculations for part 3 of part A of question 5 done in one way, and these are the calculations done in a different way. With that, we have come to the end of this video. So as always, I'd like to say thanks for watching, and I hope you've learned something.